very happy to teach you geology, some geology. Okay. And thank you very much for the invitation for this talk, Mr. Director. And thank you, Monseigneur, and the member of the board for being here. Okay, so since a few years, I've been less involved in direct science because I retired, and as you know, in France, it's difficult to come back to active science, but there is plenty of things to do as well. And I've been working with my brother Georges, another geologist, by the way, former professor at Grenoble University. So we are doing a team, a land geologist and a marine geologist all together. And we have been working on several sides of the Mediterranean Sea. And as you can see from this slide, the Mediterranean Sea cannot see only as a sea, but should be seen also. Yes. Non, je veux le pointeur.
Ah oui, ça c'est un problème pour moi aussi.
Non.
Oui, c'est pas mon mérite.
Non, c'est le pointeur. Oui, mais il faut qu'il... Voilà. Merci. On me l'avait montré, mais j'ai déjà oublié. Okay. So as you can see, the Mediterranean Sea, and I display this slide intentionally, is not only a sea, but it's a sea surrounded by mountain chain. And when you are talking about earth science and Mediterranean, in fact, you should keep in mind Mediterranean domain, because this is a full domain, at least for the geology. I don't mean for the oceanography as well, but for the geology, it's a full domain. And what you see here, one day, we have to be patient, sure, will be probably incorporated at the junction in between the European plate here and the African plate. In fact, it's about 80 million years. Geology has a time for her, 80 million years that the two plates are converging together. And the result of what you can see here, the Alps, the Apennines, the prolongation of the Alps through Greece and even Turkey, are what? They are the remains of former Mediterranean Sea, probably bigger than the Mediterranean Sea now, but which has been incorporated into Europe by the collision in between a plate or subplate related to both of them. And last on this slide, the next upcoming mountain chain, which will be incorporated into the system, is there. In its formation in between Libya, Egypt, and southern Greece, as you can see here. Okay, southern Greece as a whole, and this area, the Mediterranean ridge, is in fact a submarine mountain chain in its making. So it's quite important to consider this. So the tribute of earth science to the Mediterranean, I want to show you that, in fact, geology is clearly related to the presence of the Mediterranean Sea, and from a long time now. One of the first people who has been talking in terms of geology is Plato. So we are at 500th century before Christus, and Plato, in fact, visited 2 times Sicily and the area of Sciacca, which is a beautiful fisherman harbor on this coast, and the area of Arragona, not too far from Agrigent, which is here. And Plato was not coming to do geology. In fact, he was visiting the tyrant from Syracuse. His name was Dionysus. Tyrant. At Plato, democracy. In fact, Plato was trying to learn democracy to the tyrant, but didn't succeed in this case. So probably decided to see something else. And he went to Sciacca, and in Sciacca, he visited already caves which are emitting gas and which are warm and which are still used, not the caves, but there are in Chiaca important balnearic area in which people are still using to go. Plateau, during his second trip, second journey in Sicily, visited Aragona, where he saw what can be seen still today, mud volcano. As you know, mud volcanoes are one of the processes which are quite important in the Mediterranean Sea. I will show you that later on. But there are outcropping mud volcanoes in southern Sicily, nearby Agrigent. The next guys who have been involved into geology at some stage are those three people, Aristotle, Lucretia, and Pliny the Older. All of them have been speculated on mineral formation. Even if they were not trying to explain the formation of the mineral, they were trying to classify the mineral in terms of their beauty or things like that. Okay, the three of them. And then we jump to two people. I made a choice because we can have a look on many of those scientists from the past. But the two important to my case are Eratosthenes and Strabon. Eratosthenes was the director of the Alexandria Library. The Library of Alexandria was created about 300 years before Christus by Ptolemy, in fact, one of the generals of Alexander, in fact. And Eratosthenes has been the third or fourth director of this library, and he has been the guy far away before Magellan, which demonstrated that the Earth was quite circular. He made the measurement of the Earth's diameter by that time, okay? And Eratosthenes did a kind of geography of the world by that time, which has been synthesized later on in Renaissance time according to what he wrote. And as you can see, the Mediterranean Sea was already relatively well shown, the center of the world, by the way, and you can see that Africa was already relatively well known, even at least to the part of nearby Somalia in this area. Arabia was relatively well mapped, and even the Hormuz Strait was represented on this map. For the rest of the world is quite simple. Okay, Strabo also, but what is interesting, I forget to mention, what is interesting in Eratosthenes' writing is that he was talking about sea level fluctuation already by that time, knowing that shell were found at different levels in some part of northern Africa. By the way, Eratosthenes was born in Libya. He was a Greek born in Libya. And looking on shell at different levels, he was explaining the occurrence of those shells by sea level fluctuation. So sea level fluctuation were already assumed by that time. Strabo, another great philosopher, scientist born in southern Turkey, Strabo, has proposed a kind of relationship in between the Mediterranean Strait, like Gibraltar and other straits, and seismic and volcanic activity. So it was also already a very interesting idea among those people within the past. Now, if we look on one of the famous scientists in the antique time, we jump on Pliny the Young, Pliny the Young was really, why he was a young? Because we have Pliny the Older, which was his uncle, and Pliny the Young has given really the first detailed description of a volcanic eruption with the eruption of Vesuvius and the catastrophic event of Pompeii. He was a young man in doing that because this eruption was in 79. So he was only 18, 19 years old when he saw his uncle disappearing, in fact, during this catastrophic event. But it's really the first detailed description of volcanic eruption. So we are still in the antique time, and you see that several concepts of geology are already proposed by those people, and I forget to mention many of them because we have no time to do that. Okay, now we make a jump. And we have been talking about Magellan. Great guy, no problem. But we have also 500-year anniversary in this case for Leonardo. Leonardo died in also, not like Magellan. Magellan was sailing, but he died in 21. No? He died in 21, 2 years later after Leonardo in the Philippines. Okay, and Leonardo was one of the scientists during that time, interested also by some aspect of geology, and in one of his codex, we can find the tracing of the Arno River. You see the Arno River in this case, the main course of the Arno River. But he was looking on the abandoned divagation, abandoned course of the Arno River within the General Valley. And he made a very nice drawing of the Arno River itself by that time, and the several course of the Arno River. So it was some geomorphology as given by Leonardo 500 years ago. Okay? And now we have another jump at about 100 years after. And this guy, Nicolas Stenson, is in fact the first real creator of geology. Why am I saying that? He demonstrated, he demonstrated that based on its observation, he was a bishop, I forget to mention, a bishop of the Catholic Church, Danish, but working for the Pope in Rome, and he was traveling in Tuscany, and by observing the rocks in Tuscany, he was the first to talk about stratigraphy, superposition, and specifying that the upper layer was younger than the layer down below. Okay, he was facing some difficulty because being a bishop, he was not really free to mention the age of what he was looking, because everything should have been started made in 6 days, and the Noah flood would have been also something very important, and he was not able really to face this problem due to the dogma of the church by that time. He described also fossils, and all those observations, which are in fact the founding of geology, have been published in 1669 in a book. You can see the cover of this book on this slide. So after that, I jump to another very good scientist. He was more or less like Admiral Philip II, a man which was not only a military, but which was also a diplomat, and which was also a scientist. So a kind of universal man. And our Luigi Ferdinando Marsili, in fact, during his functioned as a diplomat or as a military, as a soldier, was also looking on the various countries in which he was by that time, including on the Danube. He published many things, in fact, and he was the first to publish a book on the ocean. And not only in this book, he was also the first to trace, if you see, the mountain chain across Italy, across Sicily, across Greece mainland. And you cannot see exactly here, but looking on this piece of mountain chain, on this piece of the Apennine, he even put a submerged mountain chain across Otranto Strait, which doesn't exist, but it was a proposal that he made. He made also speculation of the interior of the Earth and things like that, and published section of the Earth by that time. Okay. We jump again into the story. We are still before plate tectonic, and one of the great geologists for the Mediterranean, but not only, was Edward Suess. Edward Suess published The Face of the Earth and was the creator of the concept of Gondwana and Tethys. But I selected this map, you know, because Suess has also his knowledge of the Mediterranean was quite more important than what it is now. In fact, for Suess, as I told you before, the plate tectonic doesn't exist, and in Jurassic time, he made the observation that in Jurassic, many Jurassic outcrops in South America or in Africa or in North America and in Europe are more or less similar. And this gave him the idea of a super Gondwana continent and a super Laurasia continent. But not knowing the plate tectonic, the Mediterranean was separating those two continents. And you see the Mediterranean was more or less where is the northern, Central Atlantic by now. Okay. I also selected a scientist, not for you, but because I consider that Émile Argan, he was a Swiss working in Geneva, no, in Neuchâtel. He was an autodidact at first, not knowing nothing in geology, but by having a great knowledge of all the literature. Émile Argan has been one of the scientists, probably the first scientist, to define Alpine tectonic, the tectonic of Asia, and emphasizing the lateral motion across the Alpine. And you can see on this sketch of the opening of the Mediterranean Sea in 4 stages, from 28, 38, 18, 11, and now. The opening of the Mediterranean Sea, this was proposed in 1924, far away before the plate tectonic again. And you can see even the dating is quite good compared to what is known now. Just to show you that, we are here 90 years later, and in fact, we are at the same age, and we are more or less, except that there is on this cartoon a little more detail, but we are exactly in the same type of reconstruction that the one which were proposed almost a century ago by Émile Argan, which is amazing, in fact, to see that. Now I am switching to the marine geology side of the impact on the Mediterranean Sea. In fact, marine geology has not been starting only in the Mediterranean Sea because it started in several places together, but Jacques Bourcard, a French professor, once working in Villefranche-sur-Mer, has been one of the first to publish in the publication of the Musée Oceanographique de Monaco this map, which dates back to 1959, and which is based, in fact, on the first electronic result, if we can say not electronic, but acoustic result. In fact, Burckhardt had access in the late World War II, in the late 40s, to data which were collected before by acoustic device, but which were kept as secret, military secret, not classified, if we can say, because they were very important for the submarine potentially. And after World War II, those data were declassified. Burckhardt had access to those data and compiled all those data collected by the French Navy in the Gulf of Lion and along the French continental margin of the Mediterranean Sea, and published a very detailed map. So we do have now more detail, but this map is already a piece of work which is quite important by that time. And Burckhardt defined what he used to call the precontinent, which we can translate now by continental margin, in fact. Okay. And then I'm switching to modern marine geology in the Mediterranean Sea. I'm sorry for our colleagues from Italy, Spain, Portugal, Greece, or whatever, but it was much more easy for me to select French vessel. So we had access soon after Burckhardt, not soon after Burckhardt, but in the 70, 80, to those type of tools that we were using to do what the hydrographic office are doing. This vessel, for example, is a Botan-Beaupré. You know the Botan-Beaupré belongs to both Ifremer and the French Navy Hydrographic Office, as well as the Pourquoi Pas is a sharing research vessel in between Ifremer and the French Navy and used for the French Hydrographic Office as well. So using those vessels, we have been able to produce much more detailed map, but not too far from the one published by Burckhardt, in fact, except that we have detail. And here you have a map of the French and Italian border of the continental margin in the Ligurian Sea, which is quite detailed. And Monaco is here, as you can see, and you can see here the Canyon of Monaco shown on this map. But having access to this tool, we can go further to refined bathymetry, like this one. We have seen yesterday a presentation on slide along the continental margin of Israel. Here you have several scars which have been created by a large slide along the continental margin of Liguria. And I was showing the Canyon of Monaco because this is the Canyon of Monaco. And you can, sorry. Too quick. Okay. And what you can see on this is, as far as you have access to more detailed technological tool, more detail you can see. Here you see the map as derived from the sea surface ship, and here you see transect as derived from AUV, automatic undersea vehicle, showing you the detail at a 2 DTM meter. And you can see that, in fact, a large scar like that is probably a series of smaller scars which are all put together in one scar that you can map from the seabed, from the sea surface, sorry. Just because it's quite interesting also, many people traveling or visiting the Stromboli didn't see that the Stromboli is bigger or as big as the Etna, as seen on this beautiful map published by our colleagues from Bologna, based on SWAT bathymetric data. And if you see the small cartoon just down, one is the Etna here and one is the Stromboli. So when you are traveling nearby or sailing nearby the Stromboli, it looks like a small island, even if it's relatively big. But if you put this island into its the central part of the huge volcano, you can see that. Okay. Okay, but to show you that SWOT mapping is also quite important at a shallow level, and this is where I want to come at some stage. Here you have the Villefranche Bay area mapped by SWOT mapping with a 2-meter DTM, and you can see a lot of detail that I'm not giving to give you in that, but you can see former coastline due to the progressive invasion by the sea during Quaternaire time into a former aerial valley. And we know that this is an aerial valley because we know that this is probably a dolin. For the non-geologist, a dolin is an area which is the result of transformation by meteoritic water, let's say rain of carbonate, dissolution of the carbonate, like you do have in several parts of the karst area, for example. Okay. Another tool to which we had access, it's MCS, seismic reflection profiling, even if our friends from the Wales don't like this system. This system has been revealing a lot on the geology of the Mediterranean Sea. And as an example, you have this seismic reflection line, which is a kind of scan of the thin skin of the surface of the Mediterranean Sea, in which you can see on several kilometers the various geological layers, and I would like to draw your attention on this layer, which is made of massive salt being interbedded like a piece of ham into a sandwich of sedimentary layer which are here. So this is probably several kilometers, 6 to 7 kilometers. The basement will be here. You have the beginning of the fading by sediment of the Mediterranean Sea, and here the result of the dry up of the Mediterranean Sea during the so-called Messinian stage, deposited in the Mediterranean Sea, and after the seawater was again invading the Mediterranean Sea and has deposited. So we could not illustrate this without seismic profiling. Another tool which has been very important for the knowledge of the Mediterranean Sea are those results of deep-sea drilling in the Mediterranean Sea, which have been made in between 1970 to 1995, roughly, during 25 years. Nothing has been happening until recently at this level, but this has brought a lot of data correlating the seismic lines that I showed you before to real geology. This is the type of vessel we use. This is the type of vessel which can be used as well, built by the Japanese to do that. And this is one of the results from deep-sea drilling. You can see here what we call a serpentinite. It's an upper mantle rock. So a piece of rock which is usually at 30 kilometers below the Earth's crust, but which is practically outcropping in the central part of the Tyrrhenian Sea, the Tyrrhenian Sea being so stretched. Okay? Last, access to those type of tools, submersible, ROV, AUV, and thanks to those tools, we have another type of observation which can be made directly on the seabed of the Mediterranean Sea. Here you have two views of salt, brine, and mud, brine and hot brine, sorry, on a mud volcano by 3,000 meters of water depth on the Egyptian margin, and you can see a lake in this area. This lake is fed by, this type of material, which is a mixing of saumure and bacterial mat and so on, which are merging from about 600 meters from this lake, and which we can observe, sample, measure, thanks to those type of tools. Okay. And we know, using SWOT mapping and seismic exploration, that those mud volcanoes, similar to this one, are quite widespread in the eastern Mediterranean Sea, for example. And this is a map of this type of mud volcano in the Mediterranean Sea, eastern Mediterranean Sea. Now I'm going back to what has been shown several times today, or stressed several times today. Now the Mediterranean Sea is in fact the only sea being relatively, not totally, but well mapped, so we can understand its geological background better than in other areas. This is a compilation that we made thanks to CIESM and to several other organizations a few years ago, about 6 years ago, showing you the detailed bathymetry at a DTM at 500 meters. We do have the same type of map. I'm not going to show it to you now for the Eastern Med at 100 DTM. So bringing more detail, more constraint, because in fact the seabed is reflecting the geological process directly. There is no erosion or almost no erosion, so you can see the result of geological process. You can see, for example, what I mentioned to you before, maybe better expressed in this area, the Mediterranean ridge in this area, which will be soon few million years, a mountain chain in this area. Okay, and last slide, maybe a little too complex, but last slide is to show you that the Mediterranean Sea results should be incorporated into synthesis of the geology around the Mediterranean Sea, and vice versa. So you can better understand the geology around the Mediterranean Sea by comparing outcrops to process which have been forming those outcrops and which are active on the seabed of the Mediterranean Sea. And I guess we should have always have this vice versa, at least for the Mediterranean Sea, in between the onshore geology and offshore geology. Just to conclude, I really would like to come back to the previous talk by Admiral Stromboli, because we urgently need now to complete this type of map and the previous map by data from the shallow part of the Mediterranean Sea. The shallow part is very crucial to better understand many of the process, to better assess earthquake, to better assess tsunami, and so on. So it's very important to follow up on what the International Hydrographic Office is proposing. Thank you very much.
Okay. Surely we have time for a few questions, and I will stress that you know, these maps, the resolution of these maps that I've seen in my own passage at CIESM has been very phenomenal. I mean, the new technology, as you said. I have a question for you, which I don't know the answer really. So, do you anticipate a major jump in technology in the next 30 years that will give you a quantum jump, say, to something else?
It's difficult to answer to your question, because, as I said, I am not in the active field by now. I'm just looking on my past, but reading what is going on. But yes, I anyway believe that there are two jumps which should be done. I am not anticipating them, but they should be done if we want to go ahead. One is systematic bathymetric mapping of the world ocean. We have seen before, during the first presentation, beautiful planet. Okay, beautiful planet mapped by the NASA. Okay, in detail. And our planet, we don't know 90% of our planet. So the jump that which should be done is clearly to map our entire planet in a way that we can see the detail on our planet similar to the detail we can see on Mars or on Neptune or whatever. It's quite important for us. It's incredible, if I can say. We are living on it, but we don't know 90% of it. Okay, this is one of the most important. So I truly follow your enthusiasm, Admiral. Okay, and as far as the scientific community is involved, they will follow you, obviously. The second point is that we don't know exactly how many of the geological processes are acting. For example, mud volcano. Mud volcanoes are emitting fluid, gas, and water or whatever, fluids. We don't know at which quantity, which timing, and so on. And those are obviously feeding the seawater, modifying the seawater, and so on. We have no idea at all of their functioning. So I guess the jump that has to be done, it's permanent recording, not on all the mud volcano, because this will be a nonsense, but selected mud volcano in order to better understand their functioning and how they interfere into the geochemical content of the seawater and so on the biology nearby the mud volcano, because they are clearly area in which bacterial first and after other organisms are progressively stored.
Question there?
I've been very impressed by your presentation. One precision about mud volcano, to stay on the field. They are 3,000 meters deep for some of them, and you can sample.
Sure. Yes. No. In fact, this has been done with, in 25 minutes, a little more, difficult to explain all the detail, but this has been done by ROV or by submarine. So those systems have their arms, and you can have the tool, and you can sample, yes. And in fact, in one of those mud volcanoes, we sample even by coring from the research vessel, and we enter into the brine, into the mixed brine, mud, and so on, by 600 meters. And we stopped the corer because the captain on board was a little afraid where I'm going now, which means that those mud, hot mud, is coming from more than kilometer depth. Yeah. So we can sample.
How come we have less bathymetric data in the shallow water than in the deep?
Why we don't?
Why? Yeah.
Why? It's because it's much longer to acquire and so much more costly to acquire. In shallow water, in fact, the bathymetric, multi-beam bathymetric data are depending on the size of the corridors that you are mapping is geometrically depending on the water depth. So if the water depth is shallow, your corridor is very narrow, and if the water depth is deep, your corridor. In fact, when I did myself several years ago the mapping of, I would say, 70% of the Eastern Mediterranean Sea, except the Ionian Sea, which have been mapped by people from Trieste, including my good friend here. We mapped by tracing our route separated by 7 kilometers, because the disposition was such that we need only the data separated by 7 kilometers. If we are doing that by 150 meters, we probably will need a 30-meter spacing, thing like that. So we need far more time. Exactly. Question
over there.
I would like to ask you one question. What do you think about the use of satellites for this kind of observation of the deeper part of the ocean? let's say, and the structure?
This is a very good question, Matthew. Thank you very much. I forget answering to the question by Frédéric Briand that development should be expected from satellite. So mapping from satellite is already done, in fact, by using the gravity data which is collected by the satellite. But the precision of the mapping, which could be derived from the gravity anomaly, is not enough to be yet compared to the precision as developed by acoustic tool using a boat. But the world map of the ocean has been already published based on satellite data, but not with the same precision. Thank you.
I think we will thank Jean for this overview, which is much more difficult to do than just giving you some very detailed thing on a neurospectrum. It reflects several years of experience, I would say, and it's good to see that you are still active. Jean, please take a seat, and we are going to conclude this panel with Dr. Emmanuel.